Okay, so now that we've sort of gotten all that together, the next thing we need to talk about is network topology diagrams. So if you're going to get into the job of computer networking in any way, you're going to have to understand what's a topology diagram and when would I use it? So a network topology diagram is sort of like a visual representation, like a map of the network. Think about a street map, right? When someone gives you a street map, what do you use that for? You use that to see, okay, which street connects to which other street, which streets terminate at a park or maybe at a lake. It shows you how everything's laid out. Well, network topology diagram is the exact same thing, but for your computer network. It shows you how everything's laid out, what's connected to what, where my connectors run, where my host devices might be, where my network access devices like my access points and my switches might live, where my network infrastructure devices like my routers might be, and how everything's connected together. So let's take a look at this right here to give you just sort of an idea as to what these are. So in a network topology diagram, typically speaking, a device that looks like a hockey puck like that, that's your router. So when you see a device like that, that's a router. Now if you say, well, what's a router? That's okay. We're going to get to that in a second, but a router is a networking device, a network infrastructure device. This type of thing here that you see here, that's your switch. That is your switch. And these lines that you see here represent cables. Now in this particular network topology diagram, this is not very good because we've just discovered there's lots of different kinds of cables, right? There's shielded twisted pair, unshielded twisted pair, fiber optic, serial cables. In order for a network topology diagram to really do you any good, it has to have some sort of a key, right? Just like a regular map has a key. Your typical street map has a key that says this type of a line is a 4-lane highway. This type of a line, this dashed line, is a bike path. Same type of thing here. In order to be a decent network topology diagram, you would have to know what these type of lines represent. In many cases, not always, so you'll have to seek clarification on this when you're looking at your own network topology diagram, usually straight lines represent Ethernet connections, and these sort of broken lines here represent serial connections. Okay, so usually that's not always the case. Now if you said, well, wait a second, but is this a copper Ethernet or is this a fiber optic Ethernet? There's no way to know by looking at this. A good network topology diagram would differentiate that. They might say, okay, red lines are fiber optic and black lines are shielded twisted pair or something like that. But basically what you should take away from this is you can say this whole thing here is showing me how my devices are connected together. The lines represent the wires, the cables. And the other devices, so we've got our routers, we've got our switches, and then we have our hosts, like our laptops or our servers. Now, when someone gives you a network topology diagram, in addition to knowing what everything means, and if you don't know, you need to ask, what is this thing right here? Not sure what that represents. What is this supposed to be? What's that? You know, ask somebody so you know what you're talking about. The next thing you have to be familiar with is the network diagram you're looking at, is that an example of a logical topology or a physical topology? So let's talk a little bit about those, a logical topology versus a physical topology. And in order to talk about those a little bit, I need to bring up a whiteboard. So let me go ahead and get that set up here. Okay, so let's start with a physical topology. And just like it sounds, a physical topology diagram shows you everything there is from point A to point B. So for example, a physical topology might look like this. Let's say that you're at home and this is your laptop. And let's say that via your laptop, you're connected via Wi-Fi to an access point. So I'll just sort of draw these little lines here to represent your wireless connection. And then you've got an access point here that's got some antennas sticking out of it that's listening to the wireless airwaves. And then your access point typically connects to, once again, we're talking about a home network, Probably a cable modem or a DSL modem, something like that. So let me label each one of these things here so we know exactly what we're dealing with. So here is my PC or laptop. Here is my Wi-Fi access point. And this is my cable modem. And then the cable modem in turn connects into a wall jack. And so we're talking about coaxial cable right there. And that's typically the extent of your visibility. And then in turn, that wall jack, if you actually were able to trace the cable, it goes several miles to some other networking devices. And I'm just going to draw them here. And then maybe at the far end is the server you're actually connecting to. Let's just say Google's server. So maybe we'll just say that these two circles are routers. And this is the server that's hosting your web page. Okay, so now this is an example of a physical diagram. It is showing you everything in place in order to get the data from your laptop over the airwaves to the wire connecting to your cable modem, to the wire that connects to your wall, that then goes miles to the cable service provider, you know, Time Warner Cable, Comcast, whoever your service provider is. And then there's more cables connecting to routers, and eventually there's a cable that connects to the web server that actually has the website that you're trying to get to. So this is a physical topology. Now, from your laptop's perspective, your laptop is not aware of all this. If you went into your laptop and you try to see, okay, where in my laptop can I see that it knows about this cable here, or it knows about these two routers, or it knows about this cable right here. Your laptop doesn't know about any of that stuff. From the laptop's perspective, if you said, hey laptop, how do you see the network? The laptop would say, well, I recognize myself, and I'm running a network-aware application like my web browser, like Internet Explorer or Chrome, so I know I'm connected to a network. And my laptop would say, okay, I know I have a network interface card connected to me, and that network interface card is connecting via Wi-Fi. It's sending out wireless transmissions. And then I know that once I send out those wireless transmissions, I can bring up a website. This might be all your laptop knows. You might say, laptop, okay, it probably knows about one other thing. It probably also knows about the Wi-Fi access point. It's probably aware of that as well, because it knows that that's the thing that's picking up your wireless signals. And if you actually looked at the wireless signals itself, somewhere in the wireless signal saying, hey, access point, I've got some data for you. But that's it. If you actually looked at this, the laptop is not aware of anything beyond this point. All this stuff, let's go back here, all this stuff beyond your Wi-Fi access point connecting to the server, your laptop is not aware of that. So this right here is called a logical network topology. In other words, it's not showing us everything that's connected to everything. It's showing us from the host perspective what he thinks the network looks like. It's not the physical topology. It's what we call the logical topology. Here's another example of the differences between the two. If I was to say, tell me what the logical path is that you take to get from California to North Carolina. Okay, I'm assuming you live in the United States, but even if you don't, just think of 2 points in your country from point A to point B. So if I use that example, you say, well, the logical path I take is I get in my car, I drive to the airport, I hop on an airplane, and then I take a nap, and 4 hours later I wake up, and now I'm no longer in California, now I'm in North Carolina. And I get out of the airport, get in a rental car, and go where I'm going. Okay, but that's missing a big piece, isn't it? What about all the path that airplane had to travel from California to North Carolina? You as the passenger, do you care about that? As the passenger, do you care over what rivers and lakes and what states or countries that airplane rode over? Do you care at what elevation or height that airplane went to do different, avoid storms, and what speeds it went, and what rules that the pilots had to follow to get from the California airport to the North Carolina airport? No. As a passenger, that stuff is invisible to you. You're not even aware of that. It's still going on, but you're not aware of it. So for you, the logical network, the logical path looks like car to airport, airport to airport to car, and then you're done. But the physical network is all that stuff in the middle. The physical network is every single stop sign you had to go through, every single stop light you had to go through, every intersection you had to go through before you got to the airport. And then once you got there, every rule and policy in place that the airlines had to follow and the pilots had to follow to fly from one airport to the other, and all the stops in between. If we take into consideration all of that stuff, that is the physical path that you as a human being had to take to get from point A in North Carolina to point A in California. And network topology diagrams are exactly the same way. Now, a more realistic viewpoint. Somebody might say, hey, I have a problem with my network. And you might say, okay, well, as your network troubleshooter, I'm going to help you. They say, okay, here's my problem. I've got Joe's PC right here. And Joe's PC is trying to connect to our company's email server. And Joe can't get his email. And you say, can you send me a network topology diagram of that? And he says, oh, okay, sure, here you go. Here's your network topology diagram. Now you look at that, and if you start troubleshooting this, you might think, okay, well, this isn't going to be too hard to troubleshoot. I've got 2 devices and a cable, and that's it. But this is a logical diagram. This is not showing you what the network really looks like. If I got this from the customer, I'd have to say, okay, customer, before I start troubleshooting this, is what you've provided me the logical topology diagram or the physical topology diagram? And if they said, I don't know, what's the difference? You might say, okay, well, am I seeing every single piece of networking equipment, every single cable between Joe's PC and the email server? And the customer might say, oh, no, not really. So Joe's PC connects to a switch, which connects to another switch. And then there's that switch connects to a router, and then another router. And then there's a switch that connects to the email server. That is the physical topology. That is now showing me every component, every wire that's connecting end to end. And usually when you're doing network troubleshooting, that's what you need. The logical topology diagram is not going to do you very much good. You need to see the physical topology diagram. Now, physical topologies can be one of typically 3 different types: bus, star, and ring. So let's talk about those real quick. So in a bus topology, here's a real simple bus topology. I've got 1 cable and I've got 2 devices that are connected to that cable. So why do they call it a bus? Well, think about it if you're sitting on a bus, okay? Now I'm going to assume that you're not blind, that you can actually see. If I'm sitting on a bus, don't I see everybody else that's on that bus? Yeah. Don't I see everybody who gets on and off of that bus? Yeah, I have visibility to that. If I'm listening and I've got really good ears, isn't there even a possibility that I can hear every single conversation that's taking place on that bus? Yes, I can. Well, in a bus networking topology, the same thing is true. All the devices connected to that bus topology, they are aware of each other's presence, and they can reach each other on that same medium. Just like on that bus, I could stand up and I could go talk to the person in the first seat, or I could go talk to the person in the 10th seat, and they're all on that same bus. I don't have to get off of that bus to communicate with any of the other people on that bus. So in a bus topology, the same thing is true. Everybody on that bus topology can talk to each other directly. They don't need a switch, they don't need a router, they can talk to each other directly. That's a bus topology. Now, another type of topology that you don't see as often anymore is something called a ring topology. And that's a type of topology where we have multiple devices connected not just to one single cable and a line, but connected to a ring. Now later on, when we get a little bit deeper into networking, we're going to talk about Metro Ethernet. But Metro Ethernet is a type of network that companies typically use to connect to their service provider. And Metro Ethernet is a ring network. Now what do I mean by that? That means that there is a circle of wire, typically fiber optic cabling, that spans, 5 or 10 miles. And one company's business is tapped into that wire. And a little bit further on, another company's business is tapped into that wire. And a little further on, the service provider is tapped into that wire. So you have this big, long loop of fiber optic cabling, and these various companies are tapped into it, and that's how they get their networking connection. Now, just like on a bus, everybody connected to this ring can see each other. They have direct access to each other. All right? Everybody connected to the ring sees everybody else. So in both a bus topology, so right here, let's get rid of that for a second. We don't need that anymore. So in this, what happened to my bus topology? Let's just put that back on here. Let's put 3 PCs connected to my bus topology. So we'll say PC A, PC B, and PC C. So in a bus topology, A can talk directly to B, A can talk directly to C. They can all talk to each other on the same cable, on the same wire. Same thing is true of a ring topology. So in a ring topology, A, B, X, whatever, S, my letters are getting messed up here, but you get the idea. So in a ring topology, A can talk directly to C, he can talk directly to X, everybody can talk to everybody else. Now a third type that's very common is something called a star topology, sometimes called a hub and spoke topology. You'll see that one a lot. So here's a bunch of laptops, and these laptops are all connected to one central device. This is typically a switch. In the old days, it would have been a hub, but it's a device with a lot of ports on it, a lot of connections, a lot of NIC cards, and all the devices are connected to this. So this is what we call a star topology, because it looks like a star, like stuff radiating out from a star. Another common name for this is a hub and spoke, where the central device, whatever that is, router, switch, hub, everybody is hanging off of that. So those are the 3 different types of networking topologies you should be familiar with. We have the bus, we have the ring, and we have the star, otherwise known as hub and spoke. Now we are almost done with this section. I know it's been a long section, but there's a lot of stuff to get through here in this introduction to networking section. Oh, fully meshed versus partially meshed. This is also another important term. So in a fully meshed network, everybody connected to that network can talk to everybody else. That means fully meshed. Whereas in a partially meshed network, that's not the case. For example, let's say this circle here represents my service provider, who's providing me internet service, connection to the internet. And I'm a company that has multiple offices in different locations. All right, so let's say that this is in Boise, Idaho. Here we have Boston, Massachusetts, and here we have San Jose, California. And I call up my service provider and I say, I need to use your wide area network. Clearly I can't use a local area network because these devices are too far apart from each other. So my service provider says, okay, sure, no problem. So we'll cable you up. We'll run out a cable that connects to your Boise office and your Boston office and your San Jose office. Now the next thing they're going to ask you is, do you want a full mesh network or do you want a partial mesh network. If I say I want a full mesh network, that's what this means. That means that they're going to give me a connection from San Jose to Boise. San Jose will also be able to talk directly to Boston, and Boise will have a connection that they can use to talk to Boston. In other words, every location has a connection to every other location. So even if my San Jose building goes down, let's say San Jose completely loses power, Boise and Boston can still communicate with each other because it's fully meshed. Full mesh means everybody talks to everybody else. Now, in reality, each one of these dashed lines here, these connections, is something I'm paying for. I'm probably paying a monthly bill for each one of these. So I might look at this and say, oh, wow, well, I don't really have the money to pay for 3 connections are up all the time. And San Jose is my main central office, so I don't really need Boise and Boston to have a connection between them. I'm just going to have, if Boise and Boston need to talk to each other, they'll go through San Jose. So this is now a partially meshed connection because everybody is not connected to everybody else. So this is partial mesh. So let's put it all together. So the last thing we need to talk about is Cisco's 3-layer hierarchical design. So they're saying when you design a network, ideally, you will design it with 3 layers in mind. The first layer we need to be concerned with is something called the access layer. So all of your hosts and all of your network access devices, like your Wi-Fi access points, your switches, basically the devices that give your initial frontline community or connectivity to the network, this is called the access layer. Okay? So one thing the ICND1 is going to want you to be aware of is not only what types of devices reside at the access layer, and you should be able to answer that. That's your servers, your hosts, as well as your switches, your hubs, and your Wi-Fi access points. But they're going to want you to know, as far as the network is concerned, at this layer, what is the responsibility of the network? What types of things are going on here at the network? Well, layer 2 switching is going on here. So the network access layer provides layer 2 switching. Port security is going on here. You know, who's allowed to connect to our network and who's not. Spanning tree is going on here, which is something we're going to talk about when we get into switching. High availability, in other words, more than one switch, so in case one switch goes down, another switch can take up the job. Power over Ethernet is going on here. So for example, if I'm connecting my IP phones to the access layer, instead of having the IP phone connect into the wall jack to get electricity, I might actually be able to get electricity from the switch it's connected to. So that Ethernet cable that's carrying my data is also carrying power. It's called power over Ethernet. Now the next layer in the 3-layer design model is where we implement some routers. Because each one of these switches might be in a different floor of my building, or maybe in different buildings altogether. Maybe I've got a campus of 4 different buildings and I need to connect each building to the other one. And so I'm going to use routers to do that, and that's called my distribution layer. So in Cisco's 3-layer hierarchical design, it is at the distribution layer that you're typically going to find routing. So when you think of routing, that's going to happen here at the distribution layer. And then the 3rd layer is the core layer. And the core layer is also referenced as the network backbone. It provides high-speed network device connections to switch packets, switch your data as fast as possible. So let's bring it all back. Access layer is your network access devices are providing your frontline initial network connectivity to your laptops, your tablets, your smartphones. Those are your network access devices that resides at the access layer. Your distribution layer consists of network infrastructure devices that subdivide the network, that provide some security, that say this part of the network cannot communicate with that part of the network, or provides routing Hey, I know multiple ways to get from building 1 to building 5 on our campus. Let me select what the best path is to get from building 1 to building 5. That type of decision is made at the distribution layer. And then the core layer are your devices with your super high speed, high fast interconnections to get you from one section of the network to the other as quickly as possible. So that's the ideal approach that Cisco would like you to take, the 3-layer hierarchical design. Now, sometimes people don't have enough finances or budget to build out their network like this. Or maybe they've got such a small network that they don't really need all this. And so there's another design called the collapsed core design. And look what happens here. In the collapsed core design, now you no longer really have a distribution layer. Or what I should say is your core and your distribution have all been collapsed together. In other words, you have one device that's serving the role of the core device, in other words, your high-speed, high-switched connections, and that same device is providing you your security and your routing, which is something that's typically done at the distribution layer. So instead of having a 3-layer approach, now we have a 2-layer approach, and this is what Cisco calls the collapsed core design.